Welcome to my channel. Under solution of differential equation, today I am going to solve some examples on natural response. First, let us take problems with distinct roots. So as a first example, the problem is to find the natural response of the system described by the differential equation 4d by dt of y of t plus 8y of t is equal to x of t with initial condition y of 0 is equal to 2. So write the characteristic equation for this differential equation. To write the characteristic equation, please note this. Replace y of t by 1, d by dt of y of t by m, d square by dt square of y of t by m square, and it continues if you have a higher order of derivatives of the output terms or even the output terms. Here we have a first order differential equation. So replacing d by dt of y of t by m and y of t by 1, we get the characteristic equation which is 4m plus 8 is equal to 0, from which the solution for the characteristic equation is m is equal to minus 2. Being a first order differential equation, it has only one solution and the root of the characteristic equation is at m is equal to minus 2. So the nature of the natural response is of the form some constant into e to the power of minus 2t. Here c is the constant. To evaluate the constant, we make use of the initial condition y of 0 is equal to 2. So substitute the initial condition, that is at t is equal to 0, y of t is equal to 2. So when you put t is equal to 0 in equation 1, on the right hand side e to the power of 0 becomes 1. So we have c into 1, and on the left hand side the value of y of t at t is equal to 0 is given as 2. So substitute that for the left hand side. So we get the value for the constant in the natural response c as equal to 2. So substitute this constant value in the equation 1 to get the final natural response of the system as y n of t is equal to 2 e to the power of minus 2t. So let us take the next example where this is a second order differential equation. It's given that the system is described by the differential equation d square by dt square of y of t plus 5d by dt of y of t plus 6y of t is equal to 2x of t plus d by dt of x of t with initial conditions y of 0 is equal to 2 and d by dt of y of t at t is equal to 0 is equal to 1. To get the characteristic equation, make all the input terms 0. That is, on the right hand side what we have x of t and d by dt of x of t, make them equal to 0. So we have the right hand side is equal to 0, and on the left hand side replace y of t by 1, d by dt of y of t by m and d square by dt square of y of t by m square. So we have the characteristic equation m square plus 5m plus 6 is equal to 0, whose solution gives the roots of the characteristic equation as m is equal to minus 2 and minus 3. So they are real and also distinct. So the nature of the natural response is of the form, say constant c1 into e to the power of the first root minus 2 into t plus another constant c2 into e to the power of the second distinct root minus 3 into t. So this is our natural response which still has some constants to be evaluated. To evaluate this c1 and c2, we make use of the initial conditions that are given. So first let us substitute the first initial conditions. At t is equal to 0, the output is 2. So substituting t 0 in the equation 1, on the left hand side we have the value of the output given as 2 at t is equal to 0. And on the right hand side, when you put t is equal to 0, this e to the power of 0 becomes 1. So we have the equation c1 plus c2. So c1 plus c2 is equal to 2 is one relation that relates the two constants of this natural response, which is in terms of the constants. So to evaluate this c1 and c2, we need one more relation relating c1 and c2. To get that, we differentiate this equation 1. So what we have, d by dt of the natural response that we got is equal to minus 2 c1 e to the power of minus 2t minus 3 c2 e to the power of minus 3t. That is the equation 3 after differentiating the natural response that we got in terms of unknowns. So substitute the given initial condition, that is d by dt of y of t is 1 at t is equal to 0 in this relation. So we get on the right hand side this e to the power of 0 becomes 1. So we get minus 2c1 minus 3c2. And on the left hand side we substitute the value of the differential at t is equal to 0, that is 1. So we have the second relation minus 2c1 minus 3c2 is equal to 1, which relates c1 and c2. So from equations 2 and 4, solve for the unknowns c1 and c2. These are the constants. Solving this, we get c1 is equal to 7 and c2 is equal to minus 5. Substituting this, we get the natural response yn of t is equal to 7 e to the power of minus 2t minus 5 e to the power of minus 3t as the solution for the natural response of the given second order differential equation, which has real distinct roots. Thank you for watching. Stay tuned to get more solved examples on natural response in my next video.